Welcome to Changing Forms. Let's get started. Take a minute to look at these following functions. These functions right here are an exponential form. You've got that little x in your exponent. You got an exponent here. And these functions on the right are in logarithmic form because you have their log. Try to see if you can figure out the pattern to how this became this. You used to have the same numbers, a 3, an x, and a 9. See if you can figure out the pattern to how they moved. So let's look and see what that pattern is. Now you have log b of x equals a. So the first thing I want you to do is change this to the log of a equals x. I didn't catch that on the paper. So the log of base of a equals x. So I'm going to get rid of this and rewrite it for you. Log b of a equals x. All right. Now the b is your base. We've talked about that before. Your a is going to be your argument, and your x is going to be your exponent. So the way we go from this logarithmic form to exponential form, now you can make your own pattern once you've gotten used to this. I kind of draw mine like a heart. So I start from the b, the base, I pick up this x equals a. So b to the x equals a, because remember this is an exponent. So my b, this x becomes my exponent, equals a. So let me write that here. b to the x equals a. So let's keep practicing that here. My b, my base, to this power of 2 equals 9. So 3 to the power of 2 equals 9, which it does. 3 squared is 9. Here start at your base. 10 to the power of negative 2 equals 1 over 100. So 10 to the power of negative 2 equals 1 over 100. Again, which you could check in your calculator that it does. Now you try C on your own. When you're done, go ahead and start back over here with us. We want to change to logarithmic form. So now we're starting with this, and we want to go backwards to logarithmic form. So we have our base. Remember, this is the b to the x equals a. So my log of my base with my argument equals my exponent. And I can write that here again, although you should see it on your paper. So see, it was b to the x equals a, and then it becomes log b of a equals x. The same thing here. This will be log, and the base, the 3, is at the bottom with the 81, and the exponent right here is what it's equal to, 4. So go ahead and try C by yourself. Now, these, you do need to know how to change to exponential and logarithmic form. Really important. You're going to be doing that for the rest of the unit. But a lot of these questions, just the simply changing it, won't come up because they're going to do something a little more complicated. So for example, this is just one step more that you have to do. Solve for x. So you still have to know how to change logarithmic to exponential. So the first thing, 8 to the 4/3 equals x. It's just now you have this little extra step, which is we want to know what x is. So you can put in your calculator 8 to the power of 4/3, which you might need to put that in parentheses in your calculator, equals x. And you'll find that x equals 16. Same thing here. you've got to be able to change it. 27 to the 2/3 power equals x. But then go that extra step and find out what is 27 to the 2/3 power. Well, x equals 9. So you try yours on C. Change it and then find out what x is. Now, the last thing we're going to do is this evaluating. It's change of base. We're going to do it again later. But I just want you to know when they want you to evaluate a log, so it's not equal to anything. It's just alone here and they say evaluate. You can change that. So you can put it into your calculator, which is log of 10. So log of my argument, that a, the big number here, divided by log of my base, which is 5. So log 10 divided by log 5. And this you can put in the calculator just like this, and it'll give you a number, and in this case it's 1.43. So on B, you have log 0.75 over log of 9/16. So log of your argument, the big number, divided by log of your exponent. Put it in your calculator and you get 0.5. So go ahead and try C by yourself. That's all for now. Thanks for watching and see you soon.